Hey guys, welcome. This is Chapter 3, Test Review. Let's get to it. Booyah. 1 and 3. What kind of angles are 1 and 3? 1 and 3, I know a lot of you want to say supplementary, but they are a linear pair. We need to use linear pair as our name. They're right next to each other. Supplementary means they do add a 180, but the correct answer is a linear pair. 2 and 7, they're on the exterior of these two lines, and they are alternating, so alternate exterior angles. Okay. 5 and 8, these two are vertical angles, which we know are always congruent. 3 and 6 are going to be alternate interior, so they're on the interior, so those are alternate interior angles. 4 and 6 are same side of the transversal, so same side interior. And 1 and 5 are corresponding. If you look at 1 and 5, they are in the same relative location. If you guys notice, 1 and 5, same relative location, so that's corresponding angles. All right, given two parallel lines. Now, this is true. If you don't have parallel lines, then these angles are not either congruent or supplementary. These are alternate interior angles, so AIA. So I can set them equal to each other, and we can solve. So we're going to subtract the 3 and get 32 equals 2x, divide by 2, and x is going to equal 16. Number 8. Again, we have parallel lines, so we're going to create two equations for number 8. 47 and y minus 2 are going to be congruent because they are vertical. And we're going to go ahead and add 2 over, and we're going to get 49 equals y. And then we see that 47 and 4x minus 15, those are corresponding angles. So we can set up an equation for corresponding angles. Again, they're on parallel, so we can set them equal to each other. Corresponding angles are congruent when we have parallel lines. Add 5 over, we get 52. And then divide by 4. I just want to make sure I'm doing my numbers right. Always got to check. And we get x equals 13. Okay. Number 9, find values of x so that P is parallel to Q. So we don't know P is parallel to Q. So these two angles here are alternate exterior angles. To prove lines parallel, we have to use the converse of AEA here, and we set those two equal to each other. And if alternate exterior angles are congruent, then we have parallel lines. Add 2 over, we get 138. And 138 divided by 3, x equals 46. Number 10, again, these are corresponding angles. So we're going to use the converse of corresponding angles to prove that these two lines are parallel. So we're going to say if these were congruent, then this would work. Subtract 5 over, we get 23 equals 2x, and x will equal 11. Again, that was the converse. Whenever we prove lines parallel, use the converse. Okay. 1 and 2, so I'm going to see if I can use different colors here. 1 and 2. 1 and angle 2 is actually right there. It kind of got moved. So this is 2, 4, 3, and 8, just like that. So those are corresponding angles. Since I have parallel, very important I have parallel. Since I have parallel, we know they are congruent. So we can set those guys equal to each other. I'm going to move the 7 over there and the x over here, so we get 4x. By subtracting it, add 7 to 17, and I'm going to get, what, 24, I believe? Is that correct? Yes. And then we're going to divide by 4. We get x equals 6. 1 and 4. So we're going to use green now. 1 and angle 4 has no relationship to one another. But if you notice, 1 and 6 are congruent. So if 1 is 5x plus 10, this would also be 5x plus 10, and this is 45. So those two become same side interior, so we can add those up and set them equal to 180, just like that. 5x plus 10 plus 45, add that to 10, that's 55, and subtract from 180. And we're going to get 5x equals 125, divide by 5, and x is going to equal 25. Okay, I'm going to erase that where I plug those in so we can go ahead and reuse the picture if we need. 6 and 4, again we have 6 and 4, so here is angle 4 in purple, and 6 right there. Those are same side interior, so those are going to add up and set equal to 180. That's going to add together to give me 3x plus 30. Subtract the 30 and I get 150, and x is going to equal, I believe, 50, but we'll double check. Make sure we get it right. 50 is the answer. Okay. And 14, 1 and 8. So we're going back to the well. 1 and 8, those are alternate exterior angles. So we can set those equal to each other. Add the 2 over. Divide by 4. And x equals 33. But then I got to go ahead and plug it back in to find angle 7. Well, if I find angle 1, that's 130. 7 must be 50. Okay. Find the following if we have 72. So angle 3 is 72 degrees. So that means angle 4 is also 72. Corresponding angles, 72. Vertical, 72. So that's 3, which we already knew. 4, 7, and 5 are all 72. And then to find the other angle, we're going to subtract from 180, so we should get 108 for all the other angles. Angle 1, 108. Angle 6, 108. Angle 2, 108. Angle 8, 108. We have a nice little picture of all of them right there. Okay, let's move it and groove it. All right, find the slope of the line through these 2 points. We're going to use the slope formula. This will be given to you on the test. But you got to still label these points. Okay, so I'm going to plug it in. We're going to get 6 minus -4 over -2 minus -3. Those become positive, so I'm going to get 10 over 1, which is just 10. Do the same thing. I'm going to use the same equation right here, but I'm going to label them. y2 is 8 minus -8. -3 minus a 7. Those become positive 16 over -10. Never leave it like that. We want to go ahead and reduce the fraction. I believe 2 goes into both, so I get -8 over 5. Right equation that has a slope of -4 and a y-intercept. So we're going to use the y-intercept form, or slope-intercept form. We just plug it in. This is my slope, and this is my y-intercept. Right equation that passes through a point and has a slope, we can just use point-slope form, where we have x1, y1, and our slope. So we get y minus a -1 equals the slope of 5, x minus 2. 2 negatives makes this into a positive, and we are done. Oops, can't see that, sorry about that. But we plug those in the appropriate locations. Okay? Number 20, write the equation of a line that passes through the point -3, 5, and parallel to line y equals -x minus 4. Well, this is x1, y1, and right here is our slope of -1. Since it's parallel, we're going to have the same slope. So I'm going to use the slope of -1 and this point in this equation, so we're going to get y minus 5 equals, use the same slope, x minus the negative 3 is going to make it a positive. Okay? And number 21, we have a point and we have our slope, but it's perpendicular, so we're going to do the opposite reciprocal. So my slope isn't going to be 3, but it's going to be negative 1/3. That's what I'm going to use. Okay, so we're going to get y minus 4 equals a negative 1/3 x minus 3. Okay. Given the equation, what is the slope of the line? That's going to be 4/3. We can do this with y equals mx plus b and line things up. What is the slope of the line parallel? Well, it's going to be the same. And what's it perpendicular? We're going to do the opposite reciprocal. So notice it gets flipped and all that good stuff. All right, number 23, the slope of the two lines are parallel, perpendicular, or neither. Well, I see the reciprocals, but they're not opposite, so it is neither. 6 and negative 1/6, that's opposite reciprocal, so that's perpendicular. You can also write that with the upside down t. Is AB perpendicular to CD? Show your work to justify your answer. So here we can go ahead and use the slope formula. Y2, I'll go ahead and label these. Negative 2 minus 4 over 2 minus a negative 3. So we're going to get negative 6/5. Over here, label those. And we're going to get 2 minus a negative 3 and 8 minus 2. So that's going to become a 5/6. Those are opposite reciprocals. Are they perpendicular? Yes, perpendicular. Given the two lines, are they perpendicular? I have my slope of 1/5 and my slope of 5. No, they are reciprocals, but they are not opposite. And are these lines perpendicular? We have to solve for y, so I'm going to subtract the 4x and divide by 3. And I just care about the slope there, so I don't even have to worry about the last part. Over here, I'm going to add the 6x. So I'm going to get 8y equals 6x plus 7. Divide by 8. Doesn't matter. 6 and 8, we can reduce that to 3/4. That would be its equivalent. Are those opposite reciprocals? Yes, so we're going to say yes, perpendicular. All right, number 39. We have 3 angles. We know all the angles in a triangle add up to 180, so we just have to do x plus 3x plus x minus 5 equals 180. And we're going to get 1, 2, 3, 4, 5x minus 5 equals 180. Add the 5 over. And then divide by 5, which I don't know off the top of my head. And we're good. Over here, this is the exterior angles theorem. Or sorry, the triangle exterior angle theorem. And we're going to go ahead and set this guy equal to the sum of those guys. Those are the two remote interior. So we get 4x minus 18 equal to x plus 5 plus 2x plus 14. My lights went out. I'm going to put them back on. Unless it's easier to see, actually. I don't think it is. Okay. I don't know. It's pretty much the same. All right, so we're going to go ahead and combine like terms. It's going to be 3x. 5 plus 14 is 19. And I'm going to subtract the 3x over to get x. I'm going to add the 18 over. 19 plus 18. I'm just going to double check to make sure that's 37, and it is. And we're done. And isn't that weird? Okay. And all we have to do is find x for both those. Write equation of a line that passes through 2 points. So first we got to find the slope. And we're going to get negative 4 minus 4, negative 9 minus a negative 15. That's a negative 8 over, that's going to be 6, which reduced to negative 4/3. So there's my slope, and then I just pick one of my points. I'm going to pick that one, and we plug it into point slope form. So we got negative 4 over 3, x minus 15, which is making it look like a positive, and y minus 4. And we're done. Graph the line x equals negative 2. This is going to be pretty easy. We go to where x equals negative 2, and we make sure it only hits the x at negative 2. Doesn't hit anything else. Y equals 1, go to y equals 1. Make sure it only hits y at y equals 1. Yeah. Flip it, rip it, grip it. Proof time. All right. A is parallel to B, so we know that, so I'm going to write that in there. 1 and 2 are supplementary. We want to prove M and N are parallel. Okay. Remember, when we have to prove parallel, you want to think converse. This is huge. Think converse. Okay? So, what angles are on M and N? Well, I want to show some relationship between 2 and 3. If we can do that, we can show that M and N are parallel. Well, 2 and 3 look like same side interior, so I'm thinking if I can show they add to 180, this would be the converse of same side interior. So let's jump in. AB is parallel, 1 and 2 are supplementary, everyone's favorite, given. 1 is congruent to 3. Well, what kind of angles are 1 and 3? They are corresponding angles. We can use the corresponding angles. It's technically a postulate. If you said theorem, I'd give it to you. 3 and 2 are supplementary. Remember, how did I do that? Well, everything builds. So this statement here, a lot of students are going to want to write, oh, same side interior, right? And that would be wrong. The reason why that's wrong is because we want to scratch that out. That is not right. The reason why that's not right is because, because I don't know if M and N are parallel. That's what I'm trying to prove. So instead, I'm going to say, hey, I made this statement based upon what I had said before, right? So I said 1 and 2 are supplementary. 1 equals 3, now 3 and 2. Do you see how I am substituting here these two pieces? Okay, I probably should have done purple, but 1 and 3 are switching. So this is actually substitution property. Okay, that's what it is. And then, now that I've shown 3 and 2 are supplementary, those are same side interior, then I can use the converse of SSI. Okay? Let's look at this next one. Okay, again, I'm proving lines parallel, so I'm thinking what? Converse. It's got to be converse. Okay? A and B are parallel. Well, none of these are even shown, so I think it's A, B, C, D. So A and B are parallel. B and C are parallel. Well, I can't put it right there. Let's put it on the other side. So B and C are parallel. And then C is parallel to D. Okay. Whoa, that's a mouthful. Okay, I want to show that A is parallel to D. So this is like using like a big time transitive property. And so as you can see, we're going to get to some crazy transitive property here. So first of all, given A and 1 and 2. Okay, what kind of angles are 1 and 2? 1 and 2 are corresponding angles. They're on parallel lines, so we can use the corresponding angles postulate. And that makes me happy. 2 is congruent to 3. Well, these two are congruent because they're vertical. 3 is congruent to 4. How can I show 3 is congruent to 4? Well, they are on parallel lines, aren't they? So 3 and 4 are alternate interior angles. They're on the inside. If I cover this up and I cover that up, 3 and 4 are on the inside and they're parallel. And they're alternating. 4 is congruent to 5. Again, I cover all this up. How do I make that connection here? 4 is congruent to 5. That is an interesting connection that we made. Okay? Well, how can I show this? Well, they're alternate exterior angles. See on their outside, outside? Now if I go like this, 4 looks like it's on the inside. But cover it up, and you'll see 4 and 5 are alternate exterior angles, and they're on parallels. It's okay. Now I said 1 and 5 are congruent. Now some of you are thinking, oh, alternate exterior angles. That would be wrong, because A is not parallel to D, so I can't use that. But what I can do is I can show that I said 1 equals 2, 2 equals 3, 3 equals 4, 4 equals 5. So what must be true? 1 equals 5. So this is like the longest transitive property you've ever seen. And then A is parallel to D. Well, I showed alternate exterior angles are congruent, so I'm going to use the converse of A, E, A. Boom. Done. Dunzo, gunzo. Booyah, booyah. Alright guys, hasta luego. Thank you for your time. It's not a bobblehead. It's a bobble body.